Standard form application questions. A model rocket is launched into the air. Its height in feet, x seconds after launch, is given by this expression. The height in terms of x seconds, the height in terms of seconds is equal to negative 16x squared plus 64x plus 80. Height depends on time. I can find the height by substituting a value for x in. What's the path of this rocket going to look like? Up and down, right, Trevor? It's going to go up. Gravity's going to pull it back down. Looks kind of like a parabola. Looks kind of like a quadratic. So let's kind of sketch that out. X-axis measures seconds. The height along the y-axis. I launch it. It goes up, changes direction at the vertex, it comes back down to land on the ground sometime later. Let's ask ourselves a few things about it. What is the maximum height the rocket achieves? I think a lot of the problems that students have with these questions is, what does that mean to do? We practice finding x-intercepts. We practice finding y-intercepts. We practice finding the vertex. So which of these does that question refer to? What is the maximum height of the rocket? What point are we trying to find? Yeah, go ahead.
The vertex.
The vertex. Wouldn't the maximum height be right there? Look for those context clues in the question. I'm trying to find the maximum value, the maximum height that the rocket can get up to after I launch it into the air. So let's find the vertex. Formula necessary would be what? In standard form. What formula do I need? Finley, you're looking at it. Vertex, x-coordinate. What does that say? Vertex, standard form. You bet. Negative b over 2a. Well, I probably need to know what a, b, and c are. Paige, what's the a value? Very first number. Okay. A, b, c. So we need negative b over 2a, like Finley said. Cool. What's the opposite of positive 64? Negative 64. Divided by 2 times negative 16.
Negative 32.
Negative 64 divided by negative 32 is 2. So after 2 seconds, we know the rocket is at its highest point. Are we done?
No.
No, because what question were we asked to answer? Okay, so how do I do that then, Sydney? I know it's achieved after 2 seconds.
You take the 2 that you got for the first part of the vertex and you plug it in.
Plug it in. How high was it at 2 seconds? Don't I have a formula to find the height for any time that I might be interested in? I can find the height in terms of x seconds by plugging in how many seconds for x I had. In this case, I know it's 2. So let's take negative 16 times 2 squared. Plus 64 times 2, plus 80. Negative 16 times 2 squared, plus 64 times 2, plus 80. Evaluate and find the height after 2 seconds from launch. Mackenzie, where do I start? What operation says to do what thing first?
Do 2 squared.
What is 2 squared?
4.
Okay. So I need negative 16 times 4. Plus, let's see, 64 times 2. 64 and 64. 180. 128. Plus 80. That's where I got confused. Before I add them all together, it's 4 times 16. 64. So I'll bring down negative 64 plus 128 and 8. $144 feet. Two seconds from launch, it's at its maximum elevation of 144 feet above the surface. Well, if I know that's where the maximum height is, let's answer this. How long to reach the ground? How long till it hits the surface again? Okay. How long to reach the ground? What point does that refer to? I'm trying to understand what this means. We've been practicing how to find x and y intercept, practicing to find the vertex. What does that mean? Right, go ahead, Dan.
The largest x-intercept.
Okay, so the x-intercept. What's the height right here, Dane? What's the height when it reaches the ground?
0.
0. What x value makes the height into 0? How many seconds does it take to land, in other words? Solve for x when the height is 0. Put in other words, how long to reach the ground? Find x seconds. Find how many seconds it takes for the height to turn to 0. Let's replace that height with 0. I know the height is 0 because now it's on the ground. It's landed. That's the context clue then. Got to solve for x. Let's see if we can start factoring. Read, what can I factor out? Is there a GCF? 16, 64, and 80 can all be divided by 16. Right? You might have said 4, might have said 8, but 16 is the greatest common factor, right? Since my leading coefficient is negative 16, let's actually take out the negative with that too, just to make it easier to factor from there. What do you say, Jen? I got negative 16. What has to go here to make negative 16x squared? Right? 64x. That's negative 16 times what? 4? All I've got to is 64. I need 64x, so don't forget the x next to it. How about the 80? 80 is negative 16 times what? 5 or... Because if I put plus 5 here, that's not right.
It's negative.
It's going to be negative 5. In fact, about negative 16. So all those signs have to flip. Are we done factoring?
No.
No.
Okay, keep breaking it apart. Okay, Ben?
You would do, that would be 4, so you do negative 4, oh wait, no.
It's got to multiply to make negative
Okay,
5
so it'd be
and add to
negative
make
5
negative 4.
and cos of 1. So then you would,
Okay, so now let's think about how this is going to turn to 0. Because I want to know what number for x makes the whole thing equal to 0. What x value make x minus 5 into 0? 5. So one possible answer is 5 seconds. The other, what number plus 1 is 0? Negative 1 seconds. One of those is right, one of those isn't. Which one makes sense given the context that we're talking about? Negative 1 seconds or 5 seconds? 5 seconds. Why not the negative 1 second? Can't go backwards in time, right? Negative 1 seconds happened earlier. I don't know. We're talking about positive values. It hits the ground after 5 seconds. lands after 5 seconds. All right, you guys do this. From what height was the rocket launched? Take a minute or so, answer that question. What was the initial height of the rocket? From what height was it launched into the air? See if you can understand the question. Use the equation to find the answer. Think about where that might be at here on the graph. We'll talk about it in about a minute. If you know what point that refers to, this is probably the easiest point to find when you're in this type of equation in your standard form.
It's everything.
Okay, here's the answer. $80 feet. Where is that on the graph? Where was the rocket launched? And it.
It's the y-intercept, so it's
Okay, so it's right here. How much time has passed when the rocket was first launched into the air? Right at the time of launch. How much time had passed? 0. So isn't this asking you to find the height after 0 seconds? Find the height for when x is 0. Any point on the y-axis, the x value has to become 0. Find the height when x equals 0 seconds. Well, if you don't know how to get your answer really quick, just plug in 0 for x. What's 0 squared? 0. What's 64 times 0?
0.
So what's 80 plus 0 plus 0? Isn't this point always going to be the y-intercept then? Because that's the only number that doesn't go to 0 when you plug in 0 for x? You bet. You bet. I had graphed that up on the television screen. Using Desmos. Let's see if those points are right. I've got the path of the rocket here, where the x-axis measures time in seconds. The y-axis gives us the height of the rocket in feet. When the rocket was first launched, looks like the initial height was, 80 feet. 80 feet off the ground is where the rocket was launched, maybe on the top of some building. It initially went up into the air to a maximum height of 144 feet 2 seconds later. And then after 5 seconds, we splashed down on the ground.